Hi class, today we are going over section 1.1 for Math 101 College Algebra for Southwestern College. Let's start with question 1 on our lecture notes. Alright. All of chapter 1 should be reviewed, so I'm just going to be going through fairly quickly. If you don't do your math the same way I do for this section, you do have to make sure that it's valid steps. You don't have to do all the steps in the same order, but you have to make sure that you're adding to both sides or multiplying by both sides or dividing by both sides, etc. And that you end up with the same answer with the same notation and that you are doing it, the math, in a vertical format. So I'll be modeling the way that I would expect you to be able to do it. And if you don't do it exactly this way, it should be something fairly similar. So the first question we're doing is 2x plus 9 is equal to 5x. We're going to subtract 2x from both sides. Notice that I'm moving the variable from the left to the right. And I end up with 9 is equal to 3x. I'm going to divide both sides by 3. And then I'm going to end up with 3 is equal to x. Alright. I'm going to box my final answer, and then the other thing you want to do or understand is that you could also just put it in set notation. So our set is just a single set of braces with a value. Okay, let's do number 2. Number 2 says 6 minus 2m is equal to 3m plus 1. We're going to add 2m to both sides. And we're going to get 6 is equal to 5m plus 1. Subtract 1 from both sides because you want to move away from the variable. Get 5 is equal to 5m. Dividing both sides by 5, you should get m is equal to 1. You can also write your 1 in set notation. Alright, let's do number 3. It says 7 minus 2x minus 1 is equal to 10. And we're going to distribute that negative to the entire parentheses. So we're going to end up with a plus 1. We're going to combine like terms. So that means the 7 and the 1 are going to be added together. And so we're going to get 8. And then we're going to subtract 8 from both sides, moving it away from the variable. We get negative 2x is equal to positive 2. Dividing both sides by 2, or rather dividing both sides by negative 2, since that's the coefficient, gives me x is equal to negative 1. Once again, you can put your answer in set notation. So we're going to have it say negative 1 instead. Alright, let's do number 4. Number 4 has fractions, and I know that's everyone's favorite thing. So we have 1/2 minus 1/3 p is equal to 4/3. Alright. And whenever we're doing fractions, we want to figure out what our LCD is. Our LCD is 6. So we're going to actually take that, rewrite it, and multiply all of our fractions by 6, or rather 6 over 1. If you're not really good with fractions, I really encourage you to write your fractions when you multiply as 6 over 1, so that it reminds you you're only multiplying the numerators and not the denominators. So that's 6 divided by 2 is 3. 6 divided by 3 is 2. And then this is going to be 6 divided by 3 is 2 times 4 is 8. And if you didn't follow along with that, you need to practice your fractions. Alright, we're going to subtract 3 from both sides. And I'm going to get negative 2p is equal to 5. Dividing both sides by negative 2. That gives me p is equal to negative 5 over 2. And we'll go ahead and leave our fractions that way. And once again, you can set notation, -5/2 as your final answer. Alright, question number 5 says 0.9t is equal to 1 plus t. We're going to go ahead and multiply all the terms by 10 to get rid of the decimals. So you'll end up with 9t is equal to 10 plus 10t. Now make sure that when you multiply fractions or decimals or anything, you're going to multiply all the terms whether or not they have those fractions or decimals. So we multiplied all the terms by 10. We're going to actually move our 10t over to the left hand side. Even though it makes it negative on this side, because we don't want it to be next to the constant. So I'm going to divide both sides by negative, and so I'm going to end up with -10 as my answer. Alright, and you can write it in set notation as -10. Let's go ahead and move on to question number 6. We have 2x plus 1 over 3 plus 16 is equal to 3x. Now when we do this question, we do have a fraction, and so we are asking ourselves, what is our LCD? And our LCD in this case is 3. However, you notice that there's only one time that we have a fraction. We still want to multiply all the terms by that LCD. So this one, the LCDs will cancel out, or the fraction will cancel out. So I end up with 2x plus 1, and then say plus 48 is equal to 9x. Combining like terms, you're going to get 2x plus 49 is equal to 9x. Subtracting 2x from both sides, you end up with 49 is equal to 7x, and then dividing both sides by 7, we're going to get x is equal to 7. And I like to always put my answers in set notation, so I get x is equal to 7. Okay, question number 7 and question number 8 both have fractions in them. So I do want to make sure that you identify the LCD. I'm going to always identify them. This one is easy because it's the same on both fractions. Now, I did say something previously. You have to make sure you multiply all the terms, not just the fraction terms, but all the terms. We're going to multiply by the LCD. I'm going to put the x plus 3 here. I'm going to put x plus 3 here. I'm going to put them in parentheses. I'm also going to put x plus 3 here. So you need to make sure that you do that, and this will cancel out, and this will cancel out, and that can't cancel out. So I'm going to keep some of the terms. The 2x doesn't change. Minus 6 doesn't change, but this one does, and I get -2 times x plus 3. I'm just going to do it one more time so you can follow along easily. I'm going to get 2x is equal to -6 minus 2x minus 6. Now combining like terms, because those are on the same side of the equation, that's -2x minus 12. And I'm going to add 2x to both sides because I want to move this variable here away from the 12. And so I end up with 4x is equal to -12, dividing both sides by 4. Oops. Dividing both sides by 4, I get x is equal to -3. Okay, I know I just boxed my answer, but let's take a look at this. When I start off with this question, I really should have said, hey, look, I have a variable in the denominator, and I don't know what my answer is going to be, but I need to check to make sure I know if there's any restrictions. And there are. My denominator cannot be 0, and if I plug this in, I'm going to get 2x over negative 3 plus 3, and I could write the rest, but basically this portion becomes 2x over 0. We can't have a fraction over 0, so we have to throw this whole thing out. We can't have that as an answer. So we have to throw it out, and we have to say no solution. In other words, the empty set. So this right here, just want to make sure you understand. That right there, the 0 with a line through it, means no solution. You cannot use that as your 0 for class. Okay, number 8. We want to identify the LCD. And here the LCD is going to be the phrase x squared minus 9. You need to make sure that that can reduce with all the fractions. So I'm going to rewrite this once. I'm just going to give myself some space to write that LCD in the numerator of all the fractions. And I'm sort of exaggerating my fractions. But I'm going to write the x squared minus 9 in the numerator. And over here I'm going to write it in factored form, x plus 3, x minus 3, and here we have x squared minus 9. Those are actually all the same numerators. I'm just writing some of them in regular format, or multiplied out, and some in factored form. You're going to reduce them, and because we chose the LCD, that means I'm not going to have any fractions left over. I do have to do some multiplying out. We'll do it on our next step. Just want to clean it up and make it look nicer. The x plus 4x minus 12 is equal to 3. Now combining like terms, we're going to get 5x minus 12 is equal to 3. We're going to add 12 to both sides to move this constant away from the variable. I'm going to get 5x is equal to 15. And so dividing both sides by 5, I get x equals 3. Alright. Now, once again, we want to check if this works as an answer. And when I plug it in, I should find, I get 3 is equal to 3 squared minus 9. And that's going to be 3 is equal to 9 minus 9, which means I get 3 over 0. Oh boy, I can't have 0 as my fraction answer. I have to throw it out. This doesn't work. And once again, I have no solution. Alright, so we have question number 9. It's a word problem. And one of the things you want to do when you work with word problems is set up your variables. So reading ahead, it says, what is its list price? I'm just going to go ahead and underline this portion right here. That is what we were looking for. It's always sort of the end question. And so we want to write list price as our variable. So I'll just call that variable P. Or you can call it X or whatever you want to call it. Now, reading the problem, it says that the list price was reduced by 15%. And so it starts off at 100% and it gets reduced by 15%. And so the discounted price is $18,000. So you say, if I take away 15%, you're going to have 100% minus 15%. Now I'm writing it in percentages and words. But I'm going to convert this right now to an equation. So 100% minus 15% is 85%. But 85% we're going to write as a decimal, so I'm going to say 0.85 times P, and that's going to be the discounted price. In the word problem, the discounted price is $18,000. So in order to solve for P, you're going to divide both sides by 0.85. And so I'm going to say P is, and I'm not doing this in my head, my calculator did it for me, is 21176.47. So $21,176.47. We just answered the first question. The first question is, what is the list price? The list price is $21,176.47. How much can be saved by purchasing last year's model? So if we know it was 21,000 something, we're going to subtract last year's model to get our second answer, and that's going to be $3,176.47. Once again, I used my calculator for that. You can save that much money. So I wrote it in a different color, but that's answering the second question. And you always have to make sure when you're doing a word problem that you answer the question that's asked. If they asked how much we saved and we said 21,000, that would not be the right answer. Its price was 21,000, but we saved 3,000 approximately. So you just want to make sure that your answers always match the question that's asked. Alright, the last question for this section. The perimeter of a rectangle is 42 meters. Find the length and width if the length is twice the width. So we're going to draw a rectangle because the word says rectangle. And we're going to label it according to some of the words given to us. So this is L, and this is W for length and width. And I'm going to take this portion of the sentence, that if the length is twice the width. I'm going to write that as an algebraic phrase. So the length is twice the width. Alright. So then the other thing that we know is that the rectangle, the perimeter is 42 meters. And so I'm going to say the perimeter is 42 meters. Now that might seem like, why do I have so many letters going on? What's going on with this? But we should know certain things. So the perimeter of a rectangle is adding up all the sides. If you don't know the formula, you could make it up because you can add up all the sides. But you would have 2 lengths and 2 widths. Now we can't solve that because that's still too many things. But what I can do is substitute some of these values over here into that equation that I know. So I'm going to say instead of P for perimeter, I'm going to say 42. I'm going to say 2. Instead of length, I'm going to say twice the width. And then I'm going to keep my W. So now, instead of having P and L and W in my equation, I only have W's. I'm going to go ahead and simplify this. And I'm going to combine like terms. I'm going to divide by 6. And I'm going to get, and I'm going to get 7 as my answer. Now 7 is just one of the answers. I was asked to find its length and the width. And right now, the only thing I found is the width. So I need to take that information and plug it back into that equation there. And so I'm going to say the length is twice the width. And the width I know is 7. So my length is 14. And that's my second answer. Now, I know I boxed it already, but we do have to make sure that we answer the question in the format that's asked. So the length is 14 meters using the correct units of measurements, and the width is 7 meters. That would be a better answer, because you do want to use the unit of measurements that the problem is. Otherwise, you're going to miss a point. Alright, so once again, I want to go over this. After I drew the rectangle, I wrote down some of the information given in the word problem. And then I had to come up with this equation, which was the equation for perimeter, which I should have already known. And then I'm taking this information and plugging it into that equation to be able to have a one variable equation to solve. So that was the method. Make sure you always write down your equations and write down what the problem says so that you can do your substitutions correctly. And that's it for section 1.1.